Please dedicate a few minutes to our video. We're happy to share with you our experience in understanding and solving problems during SSD development. SSD developers spend significant effort behind lower than planned quality of service and unexpected crashes. Many of these issues are due to incorrect hardware and firmware management of the NAND devices, not facing correctly the challenges of the latest NAND technologies and interface speeds. All-inclusive NAND characterization, if correctly executed, reduces the reworks during SSD prototyping and ensures reliable, high-performance products. M+T's Nanocycler offers a one-stop solution to collect and analyze all NAND-related information. The SSD firmware needs to know how the NAND characteristics change during aging and has to take the corrective actions, usually the adjustment of the read levels. This adjustment, the so-called read-retry, is expensive in terms of execution time. If we know in advance which is probably the best setting, we can reduce the error flow trigger rate, which results in better overall quality of service. To find the optimal read levels without runtime search, characterization provides the correct settings. The characterization has to simulate perfectly the real-life usage, as frequency of reads and writes, temperature, and so on. Nanocycler provides a hardware and software platform, optimized to run a large number of independent experiments at the same time. The built-in intelligence accelerates the process to get reliable characterization results. Crashes and other hard-to-explain behaviors are often caused by the incorrect powering subsystem of the SSD. It is economically not reasonable to design this subsystem for the worst case indicated by the NAND datasheet. As NAND power consumption is very variable during the read-write-erase operations, a good filtering system and correct layout is needed to provide good quality supplies. In order to optimize the power subsystem in terms of quality, economics and size, it is essential to learn about the NAND current consumption, getting data also about waveforms and peak values beyond average current. Nanocycler embeds a flexible current measurement engine with waveform capture, peak detection and average measurement on all NAND supplies. NAND devices have inherent read errors, so the first priority is to eliminate all other data transmission error sources. Error-free communication between the controller and the NAND device can be obtained with correct layout design, proper on-die termination settings, and efficient training algorithm. When the channel speed exceeds 800 megatransfer per second, interface-induced bit error ratio further challenges the ECC LDPC engine and might slow down its operation. The correct design requires the knowledge of the optimal sampling timing and the available window. Nanocycler has a built-in, high-resolution timing analyzer, able to measure the margins of the NAND signals. Nanocycler also supports the validation of custom training algorithms in a more friendly environment than the controller itself. The NAND interface speed is increasing. Today's devices support speeds higher than 800 megatransfer per second, reaching 1033 megatransfer per second, 1200 or even 1.6 gigatransfer per second. The higher interface speed, besides making it more difficult to create an error-free communication channel, changes the behavior of the NAND array and operation in terms of local heating and different operation timing. Temperature may be higher and differently distributed, due to the higher power consumption of the interface circuitry. Lower page transfer times alter the relaxation effect of the NAND cells after operation. Reliable characterization results can be obtained only if the experiments faithfully simulate the final application. Studies highlighted the dependency of the generated data on the interface transfer speed. Nanocycler is able to reach a stable 1.6 gigatransfer per second, which ensures the coverage of the NAND roadmap for the coming few years. The speed and complexity of the latest TLC and QLC flash technologies set new challenges in designing large capacity, high performance SSD devices, both from the hardware point of view, like signal integrity and power management, and the firmware one, like flash algorithms and error correction. Massive amounts of accurate data must be collected and analyzed to characterize the flash endurance, errors, defects, operation timing and power. Nanocycler High Speed bundled with Barnimap Data Analytics provides the best-in-class and most cost-effective solution for the exploration of the NAND memories. Nanocycler exercises and stresses at speed up to 1.6 gigatransfer per second the devices under test, replicating faithfully the use condition of the application. Studies have proven that the interface speed has a strong impact on the quality of the characterization results. This is why it is strongly recommended to run the characterization at the same speed as the final application will run at. The speed provided by Nanocycler covers the real-life requirements for the coming 2-3 years. M+T engineers are working on the next generation beyond 2 gigatransfer per second. Nanocycler provides programmable power supplies for VCC, VCCQ and VPP, covering the ONFI voltage range with 10 mV accuracy on device. Test engineers can analyze power on-off sequences, tolerance against voltage variation, impacts of the voltage on performance and reliability. Nanocycler captures the power consumption for each supply at 50 nanoseconds sampling rate with 1 mA resolution. Flash operations power consumption data are processed in real time to provide high-resolution current consumption waveforms and key metrics, peak, average distributions over a long period of time. Several customers reported that this feature was an essential help in designing the SSD power subsystem. Nanocycler has a scalable and expandable architecture from 6 to 48 devices tested in parallel. Each test site is controlled independently by a tester unit. Tester units are connected to the central PC via Gigabit Ethernet. If the Ethernet becomes a system bottleneck because of the huge quantity of data to upload to the PC for post-analysis, we optionally offer different connection configurations via Ethernet or via PCI Express. Characterizing the NAND is very different from production testing. Instead of running the same test on a high number of devices, during characterization many different tests, experiments, run on a relatively small number of devices, often just one. The architecture of Nanocycler has been specifically designed to optimize the execution of multiple experiments. Every tester unit is fully independent. Tester units can run different test programs at different temperatures, even on different device types. It is possible to start tests asynchronously, so it is not necessary to wait until every tester unit finishes the tests, improving test equipment utilization and total cost of ownership. Barnimat, M+T's popular software tool for memory array analysis, widely used for memory technology development, has been integrated with Nanocycler to post-process data logs generated by the equipment. Dedicated functionalities customizable by the Python language help engineers to extract essential information from the huge amount of data. The combination of Nanocycler and Barnimat is the fastest, risk-free way to understand the NAND. highest quality characterization results at the lowest cost and effort. Nanocycler represents a future-safe investment to design high-performance, reliable mass storage devices.